No, I'm really excited to be here. This is going to be a little bit different than some of the other talks. But like it was said, I'm doing ephemeral Kubernetes environments for frequent high-quality releases. So a little bit about me. My name's Dan Cushing. I'm currently the DevX manager at Jasper. And I've been in DevOps for about 3 years, focused primarily on developer experience. It's something that's really exciting to me. If you followed the news lately, DevX is kind of a trending topic. I read an article the other day that Amazon has built a 400-person team. I think they call it their software builder experience team. And the purpose is to focus on some of those pain points of developers. So it's kind of cool to see a company like Amazon investing in this in such a big way. But other than that, a lot of people ask me if I play basketball because of my height. I am sorry to disappoint you guys. I am horrible at basketball. I have played a ton of StarCraft though, so if that is more your cup of tea, let me know. Always down to play some games. Cool, and then I wanted to talk briefly about Jasper before we kick things off. So hopefully you all had a chance to check out the booth. And for those of you who don't know, Jasper is an AI content platform. So you can use it to create amazing text, written content, or create original images. So I'll give you two examples. One is the Jasper blog, is written with the help of Jasper, and the other is this beautiful stained glass Keanu holding a puppy, and that's a shout out to my colleague Este. Cool. We have a really exciting engineering culture. They invest a lot in the employees, and we're hiring. So if you're interested, check out our careers page. All right, I wanted to ask you guys a question before we get started. So how many people are familiar with Kubernetes? Awesome, okay, that's a good amount. And how many of you work at companies that use Kubernetes in production? Okay, that's even more, great. Cool, so that's definitely over half. What I'm gonna do is give like a very high level refresher of Kubernetes. So the general idea is you start with your code and you containerize that. And then that code ends up as a pod. And you can think of a cluster at a very, very high level as a set of these pods. And there's this whole other layer of control plane and network and so forth that I'm not gonna get into. So given that, a common partition of environments that you see looks something like this. You have your dev cluster, and oftentimes you have stage and production. But local always exists kind of on its own off to the side, or as I like to think of it, sort of like this. But local is pretty cool, and it definitely has its advantages, and the one I want to call out is that it has a strong developer experience. This is largely due to the efficiency of local development, but it has its disadvantages as well. Because it's local, it's harder for me to then collaborate with other people. It's harder to share my changes with product design or other engineers. And then I'll also note that it's subject to bugs due to differences between your local environment and your real production Kubernetes infrastructure. So those are the benefits of local, and what about the benefits of Kubernetes? Well, in particular, I'm going to talk about a dev cluster. So it's kind of in dev where you really have the potential for collaboration. Or another way to think about it is it's a good environment where you can have these remote, ephemeral, collaborative environments. So we want them to be ephemeral so that you could spin it up quickly and tear it down. And because it's remote, in dev, now you can share that with other people. So I could share it with product or design or other engineers. And that comes at a cost. So there's a higher complexity and it's less efficient, which has an adverse impact on the developer experience. All right, so I want to give you guys a real example of when we use these collaborative environments. You might have seen Jasper Art. Jasper Art was this tremendous 1 week sprint, 5 days to get it out the door, and it required the effort of so many different teams at Jasper. So we had our front-end engineers, back-end infrastructure, we had product design, support, like all of these different teams were getting involved. And that collaboration was really made possible by these ephemeral environments. So to give you an example, just one of the environments had over 4,000 images generated by Jasper employees. It was really fun. Like, I was addicted to it that week and just generating a bunch of images. But you can imagine the amount of testing that this got in a short amount of time. So that was a really cool use case for these environments. All right. So we have the different pieces of the puzzle. We have some of the benefits of local, and we have some of the benefits of dev. And the question is, can we kind of piece these together to have an ideal environment? And so it looks something like this. We want this strong developer experience and efficiency of local, and we want the benefits that come with dev for collaboration. So that's a goal we strive for at Jasper, and I want to talk through our solution for that. So I'm going to do a little bit of a demo video, but it's primarily using a tool called Tilt. And Tilt is really just an abstraction on top of Kubernetes. So you can run it against a local cluster like Minikube, or you could run it against a dev cluster. And again, to emphasize, dev is really where you have that collaborative aspect. It's just as easy to run against dev, which is pretty cool. So essentially what Tilt does is it makes it easier and efficient to manage your services running on Kubernetes. All right, so what I'm going to do is kind of switch over to a video and show you guys this, and I'll kind of narrate as we go. All right, so the first thing that I do is I run tilt up. It's kind of like Docker Compose. It's a single command that will spin up your tech stack. And then what you're seeing is the Tilt UI. So I have defined a front-end app, a back-end service, and then a PostgreSQL database. And for this demo, I've kind of created this fictional tech stack for Planet Express Delivery Company. I'm a big fan of Futurama, so that's where that comes from. And then what I'm going to do is kind of highlight some of the key elements of the Tilt UI to talk about how it has a strong developer experience and can help with that efficiency and ease of use. So if we start with our backend service, I'm going to highlight a few key steps. So the first one is building the container. And if you think back to that diagram that I have earlier, this is the containerization piece. It's just building a Docker image. And then the next step I want to call out is actually deploying it to my cluster. And that's the getting the pod on your cluster step. So it's really just those two simple steps. And what's cool about this is now I have my backend service running in Kubernetes. And again, it's like really exciting that you can do this just as easily against dev and is very quick to do as well. All right, and then the next thing I want to call out is some extensions I've made to the Tilt UI. And the general idea is I want to add some functionality to make it easier for my developers. So in the top right, I'm going to call out those two custom buttons that I've defined. So one is for database migrate, and another is for database seed. Essentially, migrating is running Prisma Migrate under the hood, so nothing special there. And then I can seed the database as well. And in just a few seconds, I'll have a database. It's ready. It's got testing data, and we test it out. So the next thing I'll do is go to my backend service. I'm going to show you guys what this looks like. I have defined a simple resolver to get a list of crew members, to get a list of crews. And when running that, I could go back to the Tilt UI, and then you can see this last log entry at the very bottom is that crews resolver call. So essentially what this is doing is it's taking those pod logs and it's streaming it to the Tilt UI. And it's nice, it kind of abstracts some of that complexity of Kubernetes. So for developers who aren't as familiar with it, it makes it pretty easy for them. All right, now we could go and check out the front end. This is the beautiful Planet Express delivery front end. And let's say I'm having a design review and my designer wants me to change some components of the front end. So instead of saying I am lir, we want it to say deliveries and then to actually show a list of deliveries. And the exercise here is really to demo probably the most important feature of Tilt. So I could go to my code and gonna make those quick changes. I'll change the header in the front end, and then I'll go and change the back end and implement the resolver. And upon going back to the Tilt UI, you see that it's automatically restarting those pods for me. So Tilt is essentially just watching the file system. When I make a change, it detects that, it's restarting the containers, and it's redeploying it to my cluster. And that is what's really exciting to me. You don't have to wait for a deployment pipeline. It detects your change, and then in a few seconds, you've got that pushed up to your local cluster or your dev cluster. Awesome. You can see now, if I go back, I've got my list of deliveries. And then the last thing I want to do is kind of show the Tilt configuration file. This is in a language called Starlark, which is a derivative of Python. So if you're familiar with Python, this should look pretty familiar. And I'm going to call out a couple important things. On line 1, it's the Kubernetes contexts that I allow. So I allow Minikube and a dev cluster. And the point being is that you can use the same exact Tilt file for both environments, which is pretty nice. And then I'm going to highlight a couple Tilt functions. So the first is Docker build. And essentially, this is just wrapping a Docker image build under the hood. So nothing special there. And the other one is Helm resource. And this is just taking my Helm chart and applying it to the cluster. Now, the cool thing is you could kind of replicate your production deployment strategy in a way. So if I'm using Helm in production, I could use Helm in Tilt. In our case, we use Customize, so we could use Customize in Tilt. If you want to do raw YAML for any crazy reason, you could do that as well. And then I have defined a couple simple functions. So one is deploying Postgres. It's just using a third-party Helm chart. And the other is I've defined a simple function where I'm creating those buttons. It's really just wrapping system commands. And then last but not least, I have I call my functions deploy Postgres, deploy backend, and deploy frontend. So the cool thing is it's about 120 lines of configuration. It's in Python, it's going to look familiar, and you've told Tilt how to manage your services. Awesome. All right. Let me give a high-level summary, but before I do, I haven't really touched on the collaboration component of this. So to do that, essentially, instead of deploying to Minikube like I did in the demo, you would instead deploy to a dev cluster. And now you've got it remote, and all you need to do is create a way to share that around. So you could just point a DNS entry to that environment. You could then share it around. Now, my GitHub repository has some examples of how you could do that. You could use something called external DNS, but it's actually pretty easy. You're most of the way there once you've deployed that environment to dev using Tilt. So a summary is Tilt really improves that developer experience. In terms of efficiency, it reduces the complexity of Kubernetes, and it makes possible these remote collaborative ephemeral environments. All right, I've been talking a lot about efficiency, so I wanted to leave you guys with some timing metrics. So to spin up the entire Jasper stack, this is with things cached. So had I previously run Tilt and I'm using some cached images, it takes about 1 minute and 15 seconds. So it's pretty fast. And the other timing I have that I want to call out is that reload. So if I make a change to the back end in my example, it's really fast to restart that container. In fact, at Jasper, we're kind of living in that sub 30-second range when we make changes to restart those containers. Cool. I have some additional resources, so check out the GitHub repository. I have some more documentation on there. I would say definitely reach out to me if you're curious on Utah.js Slack. I would be more than happy to talk about this, and also just generally interested in hearing more about DevX in Utah. And then don't forget to check out our careers page. We're hiring, and it would be very cool if you came and worked for us. All right, I'll leave the rest of the time for questions. Yeah, we'll start over here.
Yeah, so is Tilt sort of an all-in-one solution that can install and manage a Kubernetes environment, or is it more of just a wrapper that acts as a simple interface for an existing Kubernetes installation?
Yeah, the latter is a perfect way to say that. So it's really an abstraction that runs on top of Kubernetes. It's not going to really help you set up your Kubernetes cluster, but it will help you manage the services that run on top of it. Yeah, good question.
Is Tilt installing operators and things to orchestrate within Kubernetes?
Ooh, that's a cool question. So let me give you an example. We run something called Red Panda, and there's a Red Panda operator that it's like a Kafka essentially compatible framework. You can use the Red Panda operator to set up that on your cluster. But essentially what you would do is you'd actually just use Tilt to deploy that operator to your cluster. Yeah, hopefully that made sense. Cool. Any other questions? Yeah, back waving the hand.
Is Tilt similar to Garden? Have you used that tool?
I haven't used Garden. Does anyone know the answer to that?
I'll look it up.
Okay, sounds good. You should let me know on the Utah.js Slack. Just kidding. All right, any other questions? Cool. Well, thank you guys. I appreciate it.